Dante Certification Program Level 3. Now that we've gone over QoS, class-based QoS, and DSCP, in this module, we'll go over some other specifics that are important. If you go into a Cisco switch, you might see class of service being used. Class of service relies on a layer 2 method for doing exactly what DSCP and diffserv does. It's just implemented in the Ethernet layer. It's part of the 802.1q header that we talked about earlier that's used in VLANs. Only tagged VLAN traffic will have an 802.1q header. And if we remember from before, most endpoints do not tag their packets. So what this means is that this is a QoS mechanism that's a little bit challenging to use, and you've got to do more to configure it. You've got to enable tags. Now, it can't work end-to-end because 802.1q tags get stripped. They don't make it out of the VLANs. So it's difficult to build a system if you use the class of service version as opposed to the diffserv version. The only real significant difference is that diffserv puts it in the IP packet header, while class of service puts it in the Ethernet header. There's another one that you may see called IP precedence or IPP. It supports less resolution than DSCP, so it's used less frequently in larger systems. And what network providers do dictate what switch vendors do. This in turn dictates what the industry follows, so you really don't see this being used much anywhere. On larger, more powerful and more expensive enterprise switches, QoS can be more flexible. This means it has the potential to become complicated. Switches in this category allow the network operator to cater for many different services, leveraging the flexibility and power inherent in IP. It's important to understand exactly how the QoS settings on the particular platform are implemented. Manufacturer training courses are best for this. There can be a lot of detail here. So, the question is QoS likely to make a difference? QoS can certainly help catch momentary spikes in demand and protect PTP. So if somebody creates a flood of traffic and floods a whole bunch of multicast, then it can help to protect, and that's a worthwhile thing. If you're moving 512 channels of Dante over the network link in question, you're moving about 700 to 750 megabits down that link. That still leaves you with a lot of headroom to accommodate other services down that link. Now let's remember that 100 megabits per second is still a lot of data. It is feasible that you could use QoS to run the link at a very high saturation point, say close to 95%, and still protect Dante audio. But the question is, why would you want to do that? You could just easily go out and get a 10 gig switch. It's cheaper and easier. You will generally need to have a pinch point somewhere in the network in order to see a positive benefit from QoS configuration. If you're starting to flood a gigabit network, then it's pretty cheap to go get a 10 gig core. A lot of switches now have 10 gigabit uplink ports. Or you can just make a link aggregation group. You can join two links together, make 2, 4, or 6 gigabits. So there are lots of ways you can go about solving this problem that don't necessarily need to involve complex QoS trying to squeeze that last 10% out of that link. The final point here is that it's entirely possible that you will see negative impacts if you get things wrong in complex QoS configurations where it's not really necessary. One of the most common support calls Audinate gets tends to be due to incorrect QoS configurations. If you have overconfigured your switch by any chance, you don't need to panic. Just get out a paperclip and reset the switch. Check if things work as they should. The chances are it will.